Hello, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about multi-direction current profiles in ProteusDS Oceanographic. So to start with, we're going to use one of the sample projects available, the EAC 4200, the East Australia Current 4200 meter water depth mooring. This is ProteusDS Oceanographic Designer with the file that we've downloaded from the website. So it's a pretty long mooring, over 4,000 meters long, but it still serves as a great example to play with the current profile. In Designer, you can see you can specify the current profile under Environment, but all you can put in is a single current profile speed at different depth values that you specify. This is great for most mooring designs, where this usually results in the largest mooring deflection and loads. Well, what do you do if you want to add more complexity to the current profile, having the current profile go in different headings through the water depth? Well, the answer to this is we get into that level of detail when we're looking at the current input settings in ProteusDS Simulation Toolbox. So once we're done with the detailed setup of the mooring, and this is a complete mooring ready to go, and we click on the Analyze button. And we can look at the static analysis or the dynamic. Both of what we're going to look at applies, but we're going to stick with the static analysis. And go Export. Now we need to specify the project name for the ProteusDS Simulation Toolbox files that'll be created. So I've got a subfolder I've already made here called Multi-Direction Current with a few example results already. So I'm just going to make another example here, sample multi-direction profile, and then we'll name the project file multi-direction profile, save. And it's going to open ProteusDS Simulation Toolbox. So now we're going to get into a bit more of the complicated calculations and physics simulation of what happens to the mooring in the current profile. In Proteus Simulation Toolbox, you can see we start off highlighted with the environment inputs highlighted here in the tree. And in fact, all the input files have been automatically created for us by Oceanographic Designer. And it specified a custom current profile here. This is option 5. And then there's all the custom current profile data. This is just a copy of all the information that we put in Designer at the moment. But there's another column here. There's 3 columns, right? Depth is the first data point here, and there's a description of what these items are. And then at the corresponding depth, what's the current speed you want to specify. And here's where we have another column specifying heading values that we can put in. So all of this information goes into the physics calculations. It's all sorted by depth once it's input, and then the sorted data is used to linearly interpolate between depths at what the speed is and at the heading is. And what that means is all of these points that start at higher in the water column, maybe we start at a 0 heading. And what 0 heading means is the current flow is going from the south to the north. 0 degrees is due north. And if we put in the data points in the lower portion of the water column to say 90 degrees, so this is at 1450 meters water depth and about 4,000, say 90 degrees. Now these flow points indicate the water current profile is going from the west to the east. 90 degrees is due east. And so you can add a lot more complexity in terms of what you want to happen in the current profile this way. So I'll save this. What I've done is I've got some pre-computed results. We can jump over to see what those look like. I'll open this up here. Okay, so this is what you get when you don't have any variation in the current profile. Everything is all set up at 0. So we'll open up the results, the static mooring results in PostPDS. So what I find really helpful when looking at the moorings is going to engineering view. Okay, we've got orthographic view on as well. Go to engineering view under display type. And if we set camera view looking from the east, sometimes it's helpful to show the element nodes in the mesh just to kind of show where the material properties are changing. That's what the green nodes are, but you don't have to do that. Now we're going to see with a unidirectional current profile, what does this look like? There's the deflection of the mooring. Okay, so let's look at what it looks like if we've set the current profile with 90 degrees and sort of the bottom, portion of the current profile. So open ProteusDS, we'll look at the same thing. Yeah, okay. Go to engineering view, look at east. I'm gonna put these side by side here. Okay. And well, it looks pretty similar. Maybe we can see a difference if we look top down. So we'll set the camera to looking top down. And you can see our compass here. Red corresponds to north, the 0 degree heading. So you can kind of see the mooring is like purely aligned to the north. And in this view here, this is where we had the current profile in the bottom portion of the water column. It's got a bit of a bend there towards the east. So that's from the drag, the lateral kind of drag in the lower portion of the water column. So that's what I wanted to cover, just to show you how to get a bit more detail in your current profile. Thanks for watching.